Hello and welcome to Learn Statistics class. In this class, we are going to learn statistical concepts in simple and easy way. The topic of today's lecture is basic terms of statistics. In this lecture, we are going to learn the statistical terms one by one. Let us start with first term, frequency distribution. A statistical table which shows the value of a variable arranged in the order of magnitude with respect to frequencies is called a frequency distribution. There are two types of frequency distributions. Number one, discrete frequency distribution, and second is continuous frequency distribution. Let us see the first, discrete frequency distribution. A frequency distribution in which different values of a variable along with their frequencies are shown is called a discrete frequency distribution. In discrete frequency distribution, we count how many times a particular value is repeated, and this number is the frequency of that value. If there are few values which are repeated, then we form discrete frequency distribution. Here the important step is, if there are few values which are repeated, then and then only we form discrete frequency distribution. Now let us consider an example of discrete frequency distribution to understand how we form the discrete frequency distribution. Consider the example. Following are the marks obtained by a group of 35 students in a class test of 5 marks. Form the frequency distribution. We have given 35 numbers. Solution. Here variable under consideration is marks, and few values 0, 1, 2, 3, 4 and 5 are repeated. Hence we prepare discrete frequency distribution. Calculation table. Let us write the marks in a vertical column as 0, 1, 2, 3, 4 and 5. Now we shall count the repetition of values in the given data by putting tally bars for each repetition against the value. Let us start from 0. Search 0 in the data and put tally bars. Look at the data. Here is 10. So put a tally bar against 0. Next 0 is here. Put second tally bar. Now the next, consider the next number 1. Here is 1 in the data. Put a tally bar against 1. Again in the data 1 is here. Put one tally bar. Here is also 1. Put the next tally bar. Similarly 1 is here. Put another one. Here is the fifth one. At the time of fifth repetition, we put a cross bundle. Next one is here. So put here a tally bar. In this way, in the given data there are 6 1 numbers. Similarly, count number 2 in the given data. We count the number of 2 occurring in the data and it comes out to be 8 times. Next, consider the number 3 and count the number of repetitions. Here in the data 3 is repeated 12 times and 4 occurs 4 times, 5 occurs 3 times. We count this tally bar and write in the frequency table. For 0 there are 2 tally bar, means 0 has frequency 2. Number 1 has 6 tally bar, means the number 1 has frequency 6. Similarly, 2 has frequency 8, 3 has frequency 12, 4 has frequency 4 and number 5 has frequency 3, as there are 3 tally bars. Add all this frequency, we get the total number of students in a class attending the class test. Now let us consider the next point, continuous or grouped frequency distribution. A frequency distribution in which different classes of a variable along with their frequencies are shown is called continuous or grouped frequency distribution. In continuous frequency distribution, we count the number of values falling in a particular class is counted. If there are many values which are repeated, then we form continuous frequency distribution. Here the important step is, if there are many values which are repeated, then we form continuous or grouped frequency distribution. In the discrete frequency distribution, we have seen if there are few values which are repeated, then we form the discrete frequency distribution. This is the difference between discrete frequency distribution and formation of continuous frequency distribution. Let us consider the example of calculation or formation of continuous frequency distribution in order to understand the continuous frequency distribution. Example, the following are weights in kilogram of a group of 32 persons. Construct a frequency distribution. Here we have given the weights in kilogram of 32 persons as 42 kilogram, 74 kilogram, likewise 64 kilogram, etc. Solution. In the given data, so many values from 40 to 96 are repeated. Hence, we form a continuous frequency distribution. Calculation table. We have write down the weight as x in a vertical table in the classes, in the form of classes, as first class is 40 to 50, second is 50 to 60, likewise last one is 90 to 100 kilogram. Here we count the number of values falling in a class in the given data by putting tally bar for each value against the class. Consider the class 40 to 50. and count the numbers between 40 to 50. The first number 42 is in this class. And this 40 is also in this first class, 40 to 50. So here there are 2 tally bars against this class. Similarly, we count the number of values falling in different classes. For the class 50 to 60, there are 5 numbers: 51, 53, 50, 54, 59. Now let us move to the class 60 to 70. In this way we have put the tally bar for all these classes: 40 to 50, 50 to 60, 60 70, 70 80 and 90 to 100. Now we count the number of persons by counting the number of tally bars. For the first class 40 to 50, there are 3 tally bars, hence this class has frequency 3. Similarly, next class has frequency 5. 60 to 70 has frequency 8. 70 to 80 has frequency 10. 80 to 90 has frequency 4, and last class has frequency 2. The total of all these number of persons is 32. In this way we form a continuous frequency distribution. Now let us start the next point: methods of classification. Here the data are classified according to the class interval. The first method of classification according to the class interval is inclusive method, and second one is exclusive method. Let us see the inclusive method of classification. In this method, classes are formed so that both lower and upper limit of the class are included in the same class. For example, consider the classification of number of students according to marks. Here the class 20 to 29 will contain all the items whose values are greater than or equal to 20 and less than equal to 29. In the class 20 to 29 means this number 29 is included in the same class 20 to 29. Hence this classification is called inclusive type of classification. Similarly, see for the class 50 to 59, this class contains the values of the item whose values are greater than or equal to 50 and less than equal to 59. Means this upper limit of the class is included in the same class 50 to 59. Therefore, this classification of number of students according to marks is of type inclusive classification. Let us consider the next method, exclusive method. In this method, classes are so formed that the upper limit of a class is not included in the same class. This means that the upper limit of a class is excluded from that class. For example, consider the classification of number of students according to marks. Here we have given the classes 10 to 20, 20, 30, 30, 40, etc. Likewise 70 to 80. Look at the class 10 to 20. Here this class contains the items whose values are greater than or equal to 10 but less than 20. Values in between 10 to 20 but these are greater than or equal to 10 and it must be less than 20. This number 20 is added in the next class 20 to 30. This means that the upper limit 20 in the first class is excluded from the class. So the classification is exclusive type of classification. Similarly, consider the class say 70 to 60 to 70. 60 to 70. In this class, a upper limit 70 is excluded from the class and it is included in the next class 70 to 80. This is the exclusive method of classification. Now the next term is cumulative frequency. Here to cumulate means to add. From a frequency distribution we can find how frequently a particular value of a variable or a class is occurring. It does not answer how many items have less than particular values or greater than a particular point. To answer such questions, we need cumulative frequency. The cumulative frequency is a modification of the given frequency distribution and is obtained on successively adding the frequencies of the values of variable or classes according to a certain law. The frequencies so obtained are called cumulative frequencies and they are denoted as CF. There are two types of cumulative frequencies. One, less than cumulative frequency, and second is greater than cumulative frequency. Let us see less than cumulative frequency. Here, after arranging the data in ascending order, we add up the frequencies starting from the lowest value of the variable, that is from top value of the frequency. Consider the following classification of number of students and their mark. We have given the classes 10 to 20, 20, 30, likewise 70 to 80, and the number of students are also given. There are total 100 students. Now we have to calculate the less than cumulative frequency. The less than cumulative frequency is calculated from the top of frequency, means from the top of the frequency column. Here the first frequency is 4. We will write 4 as it is. Next we have to calculate the second less than cumulative frequency. For that we add the first two frequencies, 4 plus 18, it is 22. For the third CF we add first 3, means we add the third into these two, the sum of these two frequencies, which is 22. It is 44. Similarly, for the next we add 24 with the above total of 3 frequencies, which is 44. So it is 68. Likewise, 19 plus 68, 87. Similarly, next is 10 plus 87 equal to 97. And last one is 97 plus 3 is equal to 100. At the last step we got the sum of number of all the students, which is 100. This is how we calculate a less than cumulative frequency. Let us see the next cumulative frequency, greater or more than cumulative frequency. In this, after arranging data in ascending order, we add up frequencies starting from the highest value of the variable, that is from bottom value of the frequency. For example, consider the following classification. We start from the bottom of the frequency. Here the bottom frequency is 3. Write 3 as it is. Then add last two values, 10 plus 3 equal to 13. Similarly, add first 3 last, means it is 19 plus 13 equal to 32. Similarly, 24 plus 32, 56. 22 plus 56, 78. 18 plus 78, 96. And last is 4 plus 96 is 100. This is the greater or more than cumulative frequency. Now let us move to the next point. In this lecture we have learned the 4 points. First one is frequency distribution, second is methods of classification, and third is cumulative frequency, in which we have seen the less than cumulative frequency and more than cumulative frequency. The fourth point is examples. We have seen the examples on all the above 3 points: frequency distribution, classification and cumulative frequencies. If you want to learn the more statistical basic terms, then click on the I button at the top right corner of the screen, and link of that lecture is also mentioned in the description box. In this way, we have stopped our lecture here. For more statistical concepts, we will meet in the next lecture. Till then, we will stop here. Thank you.